Hello students, in this video we will try to find relative permeability, self-inductance and energy stored in the magnetic field if we know the details of the constructed magnetic circuit. So let's read the numerical. An iron ring wound with 550 turns solenoid produces a flux density of 0.94 Tesla in the ring carrying a current of 2.4 ampere. The mean length of the iron path is 80 cm and that of air gap is 1 mm. Determine mu r for iron, self-inductance, energy stored in above arrangement if cross-sectional area of ring is 25 cm square. So let's visualize the situation or circumstances over here. So see, in this case an iron ring is mentioned. So look at this. This is an iron ring wound uniformly by some winding. It also has some air gap. So this is what a picture should look like, and now let us identify the given things. So number of turns of this winding is given to be equal to 550. So can be noted as n is equal to 550. The magnetic flux density that will be produced by this winding when it carries current of 2.4 ampere is equal to 0.94 Tesla. So B is equal to 0.94 Tesla when I is equal to 2.4. Next, length of the iron path. So see, length of the iron path, mean length of the iron path is 80 cm. So I would write Li is equal to 80 cm, and length of the air gap was given to be 1 mm. Now 1 mm is equal to 1 into 10 raised to minus 3. Now area of cross section was given to be equal to 25 cm square. So 25 into 10 raised to minus 4 meter square. Now let's start finding out the things. So see, as far as finding mu r is concerned, the formula in which mu r is present is that of the reluctance. So and reluctance over here is not only the reluctance of iron path but is also of the air path. So I would use the word total reluctance instead of simply reluctance. So total reluctance will comprise of reluctances offered by iron path as well as by air path. So total reluctance in any case can be found out by knowing MMF and dividing the value of MMF by phi. So we will proceed. MMF was not given directly but can be found out by using some formula such as N into I, and flux was also not given, so can be found out by using the formula B into I. But as I said, the reluctance is total reluctance comprising of the reluctances offered by iron and reluctance of the gap, air gap. So I am writing S is equal to Si plus Sg over here and keeping the right hand side as was written in the earlier step. Now we will move ahead. In this case, the formula for Si can also be written as Li upon mu 0 mu r I Ai, and similarly the formula for gap can also be written. So when I proceed to simplify the steps by substituting the relevant values, I get to know that mu r is, or mu r I is the only value that is unknown in the given equation now. So the terms can be rearranged and simplified so that you get the value of mu r I, and please simplify these steps as I have simplified over here, and what you get is the relative permeability for iron is 1047 in this case. Now mu r for iron is found out. Now it's time to find the self-inductance. So self-inductance can simply be found out by using its formula in its simplest form, N into phi upon I, where N is number of turns, phi is flux produced, and I is the current that was carried by the coil. So we know these values. The only thing is phi is not known directly, so phi can be written as B into A. So I can substitute the known values over here, and what I get is 538.542 into 10 raised to minus 3 or 538.542 millihenry. So self-inductance is found out. Now we will talk of finding the energy stored. We know energy stored in magnetic field by some inductive coil is given by the formula half Li square. I already know the value of L. I know the value of current that was flowing, so I can substitute these values, and what I get is 1551 millijoule is the amount of energy stored by this iron ring bearing a coil of 550 turns and carrying a current of 2.4 ampere. So see, this was quite a simple numerical, and I hope you will be able to solve such numericals where they ask to find relative permeability of the given magnetic material and then inductance and energy stored while giving the constructional details of the magnetic circuit or the solenoid. Thank you.